Okay, today we're going to learn how to graph a piecewise function and to write the equation of a piecewise function. So let's start with, given a graph, can we write the equation of a piecewise function? So we've already established on this graph, there should be 4 different equations because there are 4 different changes in the rate of change or the slope. So here's one equation, here's 2 equations, then the third one, and finally the fourth one. These are all linear functions. So I'm going to start by graphing or writing the equation of that first one. Okay, it's linear, so we can use y equals mx plus b, or we could use the point slope form, y minus y1 equals m times x minus x1. That first equation is nice because you can use the slope-intercept form because it has the slope. You can identify the slope. It rises and it runs. So here's 1 over 2. So your slope is 1/2. And you can also see where it crosses the y-axis, which is right here. And it crosses at 0, so b equals 0. So the equation of that line is just y equals 1/2 x plus 0. And you can just leave that as y equals 1/2 x. Now, this equation is there if the line went on forever. Unfortunately, this line stops at 6 and it starts at 1. So we have to write in a domain. The domain is where this graph is true. And since it has a beginning and an end, you need to tell everyone where it begins and ends. So it begins at 0, and x goes in between 6 and 0. Okay, then we write the inequality signs. So x is in between 0 and 6, and because those dots are colored in, it can equal. So 0 is less than or equal to x is less than or equal to 6. That is the domain of this equation. Oops. Don't know what happened there. Okay, now moving on to the second equation, number 2. So here's our second equation. The second equation is right here and is a horizontal line. And you can see that it would cross the y-axis at 3. Okay, and the y is always going to be 3. So that is just y equals 3. It is independent of the x values because the x keeps changing, but the y value remains constant at 3. Okay. It still also has a domain because it's only true between 6 and 8. Okay, so we say 6 and 8, and x is in between them. Since the x is equal here, we cannot have an equal sign here because then that wouldn't be a function, and this is a linear or a piecewise function. It can be equal at the 8 because it does have the closed dot. So when you're writing the domain, if you have an equal to sign on one of the domains and you have to start again, you don't put a line underneath it. You just leave it as a less than sign. Okay, the third equation is right here. We can identify the slope, up 1 over 1, up 1 over 1. So my slope is 1. I can't see the y-intercept though. If I extend that line, I wouldn't be able to tell right now. Okay, so but I can find this point here. That is 8 and 3. So I can use the point slope form of a line to write the equation. So we do y minus, the y1 is 3, is equal to the slope of 1 times x minus the x1 is 8. Then we just distribute, and I get y minus 3 equals x minus 8. Then we want to put it in slope-intercept form, so I'm going to add 3 to both sides. I'm going to get y equals x minus 5. Now I still have a domain that I need to worry about. And for this line, it's in between 8 and 12. Okay, since again it has the equal sign on the 8, I don't put the equal sign here, but I can put it on the 12 because it has the closed dots. That means it equals that point. Finally, our last equation, number 4. So we can identify the slope. I'm moving down, so that makes it negative, and to the right 1. So my slope is negative 2 over 1, which is just negative 2. Again, I can't see the y-intercept, so I'm going to have to use the point slope form and just choose a point. So here's the point that it starts at, so I can just use that, 12 and 7. So my point is 12 for x and 7 for y. And then I'm just going to plug it in. So I'm going to get y minus the y1, which is 7, equals my slope of negative 2 times x minus 12. And distribute, get y minus 7 equals negative 2x. A negative times a negative makes that positive 24. And then I'm going to add 7 to both sides. I'm going to get y equals negative 2x plus, that'd be 31. And again, I still have to worry about my domain. And my domain now is between 12 and 15. And again, my inequality signs. Since this ends, it's going to end at the 15 and it can equal it. Now I have all 4 of my equations here. Now I got to put them all together to make the piecewise function, and this is how we do that. We do f of x with this big weird bracket. The first equation. We don't need the y equals because we have the f of x equals. So it's just that first equation, which is 1/2 x. I'm going to do our semicolon and put the domain for when x is between 0 and 6. Then we move on to the second equation, which is just y equals 3. We don't need the y because we have the f of x, so it's just 3 in our semicolon of 6 is less than x is less than or equal to 8. Then we do our next one, which is the x minus 5, and our domain is 8, x, and 12. And our final one is the negative 2x plus 31 between 12 and 15. And that's how we write a piecewise function from a graph.